Okay, so I wanted to go over naming compounds, and it's a lot easier when you're first learn a set of rules and you just apply them, but it's more difficult when you're given a set of compounds to name or write the formulas for, and they're sort of mixed up, and so that's what I sort of wanted to do in this video. And so I have a combination of different things. I have sometimes I have the chemical formula and you have to name the compound, or I have its name and you have to write the formula for it. And so I sort of mixed up different compound types, and so that way we can sort of get through the process of having to name compounds when you have to consider all of the when you have to consider all the rules for naming compounds and not just one or two rules. So for the first compound here, we have MgBr2. So the first thing I'm going to do is figure out, looking at each element, which type of compound this is. Is it ionic or molecular? And so if I look on the periodic table, I'm looking at a periodic table that's color-coded based off metals, nonmetals, and metalloids. And so if I look for magnesium here, it is classified as a metal. And so if I have a metal compound, and then of course bromine is a nonmetal, a metal and a nonmetal, that means this compound is an ionic compound. Okay, so it's an ionic compound, and so now I need to ask myself, is a metal a transition metal? And so looking at where the metal is located on the periodic table, magnesium is in group 2, and so I would know to not have to use the Roman numeral in its name because magnesium always has a +2 charge, so I just have to name the elemental name for the cation, the first element, and then the second element, bromine, would become bromide. Okay, so the name for MgBr2 would be magnesium bromide. For the second example here, ruthenium 2 sulfide, I'm having to write the formula for this compound here. So I would first look up the symbol for ruthenium, my periodic table, and so it's Ru. So ruthenium is Ru, and then sulfide, that ending IDE, this is, a parent of some element, because it ends in IDE. So sulfide, not sulfate or sulfite, sulfide. So it came from sulfur, S. So now I would look at the Roman numeral. The Roman numeral tells me the charge on the metal. Okay, ruthenium is a transition metal. Here in this case, it's Roman numeral 2, so the charge on the cation for ruthenium is +2. Sulfur, I have to look to see what the charge is going to be if you look up sulfur. It is in group 16, so it has a -2 charge, and so the formula for ruthenium 2 sulfide would just be Rus. All right, for the third one here, we have another name written. I'm trying to write the formula for it. Here you notice we have prefixes that indicate the subscript number, and so the prefix for di is 2. For penta, it's 5. So all I have to write then is just the symbol for nitrogen. If I look here, because you guys are going to have to do this, look, see what the symbol for nitrogen is. It's capital N. So it would be N2, and then penta's 5. Of course, oxide came from oxygen, so the symbol for oxygen, if you look it up, it's capital O. Okay, so O and then 5. So N2O5 would be the formula for dinitrogen pentaoxide. Notice I left the A off there, okay, because you have an A and an O, and when you have two vowels like that, you tend to have to take off a letter. All right. So this fourth one here, barium iodide. So again, I need to figure out the symbols for each of these. Barium, symbol for barium, if you look that up on the periodic table, Ba. Okay. And then iodide came from iodine, right? Iodine is here, so its symbol is capital I. Okay, and now I need to figure out the subscript number. So I need to again look at where is barium located. Well, barium is located in group 2, so it's +2. And then iodine is located here in group 17, so it's -1. So the formula must be to cancel out the positive charge on the barium. I must have a -2 charge here. So I need 2 iodines. Right? We need 2 like that. So the formula would be BaI2. Now I'm writing the charges up here just to indicate so we can the charges so we can balance everything so we know what the subscripts are going to be. But in the answer you wouldn't write this. So that's why I'm rewriting it again. Okay. Without the charges there, because as a compound, each element shouldn't be charged. It's written that way, and not with the charges above there. All right. So the next one here is zinc sulfate. Oops, I didn't mean to say the answer. All right. So why is it zinc sulfate? So of course, Zn is zinc, right? If you look it up on the periodic table. Here, it's in the transition metals section. However, remember when we talked about, there's a slide that we looked at earlier in Chapter 2 that said that zinc was always +2. There's only a handful of these transition metals that are always the same charge. And so what's neat about that is you don't have to use a Roman numeral if you only have one charge, right? The only point of using a Roman numeral is if you have a transition metal that has multiple charges. So in this case, zinc only is +2. And so I'm going to show you guys quickly. Some periodic tables actually will give you, this is more of a complicated periodic table. This is only 1/2 of it. So I'm folding it in half. But here for zinc, if you can see that, zinc has, it's referred to as an oxidation number. Let me focus on that more. See, it has an oxidation number of +2. So if you get like a fancy periodic table, it will show you all the oxidation states for each element. You can't see it because of the glare. But anyways, zinc is one of those special transition metals that always has a +2 charge. I think we also talked about cadmium as well. Cadmium and zinc. And so in this case, because zinc is only +2 all the time, that means that we don't have to worry about a Roman numeral. It would be silly to indicate the charge because it's always the same thing. So its elemental name will just be zinc without the Roman numeral. And then SO4 is a polyatomic ion. It is called sulfate. This would just be zinc sulfate. All right, here we have a name, calcium phosphate. So calcium, the symbol for that is Ca. If I look that up on my periodic table, it's group 2. And then phosphate, if I had my list of polyatomic ions, if you didn't, memorize them, you could use that list, but remember on the test you cannot. So it's probably best to try to do it by memory. So the formula for phosphate is PO4. Okay, now I'm going to include each charge. So phosphate's -3, or 3-, and then calcium, because it's in group 2, is going to be +2. Okay, so remember whenever we sort of did this crisscross thing, because I can't put a 2 there, that'll be +4, and that's not going to work. So it's going to be 3 here, and then parentheses 2 there, +6 for calcium and -6 for phosphate, so they balance out. They have to add up to 0. Remember, for compounds that are neutral, they have to add up to 0. So we have a +6 for calcium, -6 for phosphate and phosphate ions, and so its final formula would be Ca3 PO4 parentheses 2. So remember, when you have a polyatomic ion and there's more than one, you have to put parentheses around the entire polyatomic ion and then put a little subscript on the outside of the parentheses indicating how many polyatomic ions you have. So the next formula here, HBr, This is a binary acid, okay, it just has hydrogen and some other, usually it's a halogen, okay, some other element. So remember, sort of the general form of naming a binary acid would be hydro, and then whatever the anion's name is, and you change the ending to ic, and then acid. So because we're dealing with HBr, bromine, so bromine becomes bromic, so the name would be hydrobromic acid. And this is true for every binary acid. Now, if you look at the types of binary acids, most of them are halogens for the anion part of the compound. So you have like HF, hydrofluoric acid, HCl, hydrochloric acid, HBr, hydrobromic acid, HI, hydroiodic acid. Okay, so those are the main binary acids that we can see and we normally use in chemistry. All right, so the next type of acid here, we have an acid, because we know acids start with hydrogen, and it has an oxygen in it, so it's an oxyacid. So it's an acid containing oxygen. Of course, it's an acid, so it contains hydrogen as well. And so with oxyacids, you have to really know your polyatomic ions, okay? Because whatever the name is, it's sort of the parent of that, or the root of the name, is coming from the polyatomic ion. So SO4 is called sulfate. Okay, and so if it ends in 8, we change that to ic, and then add the word acid, right? If it was sulfite, ite becomes OUS, us, and then acid. All right, so because it's sulfate, let me focus here. As a sulfate, it becomes sulfuric acid. Okay, 8 becomes ic, sulfuric acid. So that would be the name for H2SO4. All right, here we have a couple acid names. We have to figure out the formulas for those. All right, so when it's hydro whatever-ic acid, we know that it's a binary acid, so it has hydrogen and some other anion associated with it. Chloric came from chlorine, all right, so Cl. And so the next thing I have to do is figure out the subscripts here. Well, hydrogen is in group 1, so it's +1. Chlorine is a halogen. It's in group 17, so it's -1. So the formula for hydrochloric acid is just HCl. All right, so the next one here, nitric acid. Remember with when it's in the form of, it ends in ic or ate and then acid, that's an oxyacid, right? It has hydrogen and it has oxygen in it. And then some other element there, depending on the polyatomic ion that it came from. So ic, nitric, ic came from ate, right? And OUS came from ite. Okay, so we're sort of working backwards here like we did before. But so ic came from ate, so nitric came from nitrate. Okay, so the formula for nitrate. And that would be NO3 minus is the formula for nitrate. So let me write that in here. NO3, okay, so this whole thing, this polyatomic ion is negatively charged. The hydrogen we know is positively charged, so the formula for nitric acid is HNO3. Okay. So among all the skills that you need to know for your first exam, I think naming compounds and writing the formulas are probably the most difficult. We will encounter some math problems for you as well in Chapter 3, but hopefully you'll be able to get a grasp on that. And naming compounds too is it's easy to understand and learn, but you have to practice and be willing to practice a lot.